Today we're going to be learning how to make a line graph from our tables of ratios. So I talked to Mrs. Rue and she said that last year she touched on line graphs but didn't do a whole lot of information with them. So I wanted to give you this resource to just give you some line graph reminders. So a line graph or line chart uses straight lines to join points which represent the data. Line graphs are often used to show changes in data over a period of time. A couple of parts that always go with a line graph is you need to make sure that you always have a title. Just like when we're creating tables, we need to tell our reader what they're looking at. So when you see your title, Turtle Sightings, Far North Queensland, we know exactly what we're looking at. You also need to put an x-axis word and a y-axis word. I used to call this the x-axis label and the y-axis label, but kids kept writing x and y over here instead of writing the word that goes with it. So time is usually on the x-axis down here, and so like these are years, 2006, 2007, 2008, and then they have the label to tell us what these things are. So it says years. This is the y-axis. It goes up and down. And over here is the y-axis label or the y-axis words, number of turtles spotted. So then we know that these numbers represent those numbers of turtles that were spotted. The biggest thing about line graphs and the biggest errors we make is not having a consistent scale. So right here, there are two lines or two of these spaces here that represent 10. So here's 10. So then the next 10 would have to also be two spaces. So then it goes 10, two spaces 20, two spaces 30, two spaces 40. You can't use a different scale in between because the x and y axis are number lines. They're an intersection of number lines. So the numbers have to be spaced evenly. Down here, we start with 1 year here, we skip a line, and then we put a year. Skip a line, put a year. We can't put a year here, then put a year here, then skip a line and put a year here. So another example is our second page that you should put glue into your math notebook. So these are reminders about scale, and scale is this part over here. Sorry, I'm trying to make it focus better, but you can see it on your own page. So right here, if I start at 0 and I'm going up the y-axis, I can't go 0 to 100 and then start going by tens because I just said that this space is 100, so how can that same space be 10 and then 10 and then 10? If this is 100, then this has to be 100. So this is a no-no. Same with this one. If you start down here and your first piece of data is 3 and you use one box to represent from 0 to 3, you can't then switch and start counting by 1. That's an inconsistent scale. So if this is 3, this has to be 3. So it should go 3, 6, 9. Or it needs to go 1, 2, 3, and you have spaces there, then 3, 4, 5, 6, etc. Like right here, this is in a good scale because it's the same space and each of them represents 100, so that is an okay. This is a good scale because we went 0, skipped a line 3, skipped a line 6, skipped a line 9, so that space right there is consistent and it goes with 3. So you don't have to have a number at every tick mark, but the space must be consistent. Another option that we can use is this, and it's called a paper rip, and that's if you have a large gap in data to start with. If I don't want to do the data for turtles from year 0 of that the Earth was made, I want to start in 2000, I can do a paper rip and say, I know that there's years that happened before 2000, but it's not part of my information. So I do the paper rip, then I start 2000, and then I do a consistent scale of 5 years every time. So hopefully that helps remind you about line graphs and about using a consistent scale and making sure that your spaces all the way up from 0 and the start all the way up stay consistent.